Hello everyone and welcome to this session. So today we are going to dive into the one of the essential input devices in embedded systems. So that is switches. So switches acts as an interface to receive user inputs and making them crucial for many applications. So we will discuss different types of switches and learn how to interface a simple push button switch with an ESP32 microcontroller on the Wokwi simulator. Okay, so let's get started. In embedded systems, so switches are one of the most basic input devices. So where LED and buzzers are the basic output devices. So when coming to switches, so switches are the one of the most basic input devices. Those are used to interact with the system. Okay. So a switch is a binary device, means so it can only be one of the two states like open or closed, and we can also say it like on and off, and we can also represent it as high or low. Okay, but it holds only two states, either high or low, either on or off. Okay, so these switches are crucial in the embedded system for tasks like so turning some devices on or off and resetting the systems, or if we want our user input. So they are the commonly used in the user interfaces like in control panels, and even as a part of automated control systems we have the switches. So switch is a device for making and breaking the connections in an electrical circuit in simple. So if we want to explain about the switches in single line means so a device for making and breaking the connections in an electrical circuit. Okay, so here we have the different types of switches, right? So like we are having some rocker switch, slide switch, toggle switch, so tactile switch. So this tactile switch we can also call it as like push button, right? So we can also call it as push button. So if we take the push button, so this push button is only active when presses. When we press this push button, then only it will active. Okay, and if we releases the button means so it go back to the original state. Okay, that means to off state. Okay, so if we press the push button means so this will go to the active state. So otherwise if we release that, so it will return to its original state. Okay, and here having some toggle switch. So toggle switch so maintains its position when flipped. Okay, so if we move to the on means that will be in that on position only. So if we move to the down means it will go to the off position. Okay, so this will remains in one position until we manually change it. Okay, so that is about the toggle switch. So the slide switch also similar to the toggle switch. So when we slide the switch, so that will remains in a particular position until we manually change it. Okay, so if you observe the operation of these switches, so here you can observe this one. So this is regarding the push button type of operation. So if we press, then only the connection should happen. So otherwise it will get back to its original condition. Okay. So these type of switches so doesn't just close or open circuit. So it also plays a role in defining the logical levels so that gets read by the microcontrollers also. So when the switch is open, no current flows, right? And the system might read this as the low or high, so depending upon the circuit configuration. Okay, so when the switch is closed, so the current flows and the system will be read the opposite state. Okay, so here, so in the switch operations we have the two main concepts, so that is pull up and pull down resistors. So in embedded systems, so switches are often connected to input pins, right? So we connect it to the input pins of your microcontroller. So which needs to read the either high or low states accurately, right? So however, so when a switch is open, when the switch is open, that means not connected. So the input pin could be left floating, either high or low, so which could result in unpredictable readings. So to ensure the reliability reading, so pull up and pull down resistors are used. Okay. So to prevent the unpredictable readings in the circuit, so we will use the pull up and pull down resistors in the circuit. Okay. So if we come to the pull up resistors, so a pull up resistor connects the input pin to a high logic level. So it will connect the input pin of your microcontroller to the high logic level. So that is nothing but the VCC. So when the switch is open, so it will ensure that the total VCC will go to the microcontroller inputs. Okay. So when the switch is closed, the input pin is connected to the ground. Why? Because the voltage will always prefer the low resistance path, right? So the ground is very low resistance path. So that's why if the switch is closed, the total voltage from the VCC will go to the ground. In these conditions, at the input of the microcontroller, we will get the very low voltage. Okay. So when the switch is open, so there is no connection to the ground. So the total voltage will goes to the microcontroller. So this will ensure the inputs reach the high. So if the switch is closed, the input pin is connected to ground, and here we doesn't get any enough voltage over here at the input of the microcontroller, and this state we can call it as the low state. Okay. So this is all about the pull up resistance. So if we go for the pull down resistor, so a pull down resistor connects the input of the microcontroller to the ground. Okay. So when the switch is open, so ensuring the input leads to low. When the switch is open, so the VCC will not go to the microcontroller. Okay. So if the switch is closed, the VCC voltage will directly go to the microcontroller. Okay. So why? Because it is going to microcontroller means here we are having the resistance. So this path is having some resistance and this path doesn't contain any resistance over here. So that's why the total VCC will go to the microcontroller. And this states reach the input high. So if the switch is open means there is no input voltage because there is no connection between the VCC to the input of the microcontroller. So that state we called it as low state. Okay. So the state remains at low condition. So this is all about the pull up resistors and pull down resistors. So why we are using these pull up and pull down resistors means, so to ensure the reliable readings and to avoid the unpredictable readings in the circuit. Okay. So now we will interface one push button with the ESP32 controller. So this is the internal circuit of this push button. So it contains 4 leads. So the A and B are connected internally and C and D are connected internally. So AB and CD are internally connected. So when the switch is not pressed, there is no connection between the AB with the CD. So once the switch is pressed, so the AB leads are connected to the CD. Okay. So at the initial stage, there is no connection for the AB with the CD. So that is open circuit. So that the switch is pressed, AB are connected to the CD. So this is the internal operation of this push button. So this is all about the switches. How to connect these push buttons with the microcontrollers. So just open your browsers and search for the Wokwi.com. So in the yesterday session, we have already created the accounts in the Wokwi, right? So just go to your account. So and go to my projects and select the new project. So here which microcontroller we are going to use? So here we are having different types of microcontroller boards. So among these, which board we need to select? Yes, ESP32. So select this, simply select this ESP32. So here we have 2 more options. So regarding the programming language, so which programming language we are going to use? Here we need to select the Arduino. So once logged in, so we need to select the new project. So after that, from the list of available microcontrollers, so we need to select the ESP32. So here a new project workspace will open. So displaying a virtual ESP32 chip on the canvas. So we can call this space as the canvas. Okay. So now we need to add the components. So to add the components, so we need to click on the add button. So here we need to search for components like LEDs, buttons, sensors, displays. Okay. So here now we are going to control an LED by using a switch. Okay. So here we need to select the two components, right? So if you want to create a project with an LED, so search for LED over here. Just select the LED and you can place this LED to wherever you want on the canvas. Okay. So after placing it, again we need to add. So which component we need to add now? Yes, switch. So we need both resistor and push button. So first we will take a resistor. So if you want to rotate, so just you can press the R in your keyboard. So if you press the shift R, so the component will rotate. So why we need the resistor here? So to control the flow of current to the LED. So if we send high currents means the LED will burn out. Okay. So to prevent that, to prevent the LED to getting damaged, so we need to connect a resistor in between the positive pin of the LED to the microcontroller pin. Okay. So tell me two pins. So here I will connect LED to the second pin and I will connect push button to the fourth pin. Okay. So here, okay, in this case, so I will place the components in this side. I will just move to this side. So after placing the components, so I'm just connecting the components. Now we need to connect the positive pin of the LED to the second pin. Okay. So we will use the second pin for the LED and we will use the fourth pin for the switch. Okay. So where we need to connect this negative pin? We need to connect this pin to the ground. So here we are having the ground. So now which component we need to place? So now we need to take the push button. Okay. So as I said earlier, so it has total 4 pins A, B, C, D. So when the switch is in normal state, so there is no connection between AB with the CD. So when the switch is pressed, the connection will be formed between the AB with the CD. Okay. So just see the PPT over here. So here I just connected. So here we mentioned that AB are connected internally. So if we connected either A or B means, so we connected both the A and B because internally A and B are shorted. So we can use either this pin or either this pin. So here I am just connecting the AB pin to the GPIO pin of the controller. I am connecting the second side of the push button to the VCC. So why I am connecting means initially this is the VCC pin or VIN pin from the ESP32 controller. So when the switch is in the normal state, so this VCC will not go to this control pin. So once when the switch is pressed, so this VCC will go to this A and B and from here that will go to the fourth pin number. So then the GPIO pin reads the signal as high. So this is how the circuit will work. Okay. So now according to this, we will make the connections in the Wokwi. Okay. So here we need to connect the AB terminal of the push button to the fourth pin of the microcontroller. So from the fourth pin, I am going to connect the AB terminal of the push button. And CD terminal, we need to connect it to the VCC. So that in V in pin in the, so V in pin in the ESP32. That is, so it will supply the 5 volts to the push button. Okay. So if you want to just simulate this, so you can just run the simulation and just click on this. So it will not giving the outputs. Why? So here we just made the connections and we did not dump any program how to make the operations, right? So that's why it's not getting operated. Okay. So to make the operation and to get the proper output, so we need to write the instructions to the ESP32 microcontroller. Okay. So first we need to define the, so which GPIO pins we are using in this circuit. So here we are using 2 GPIO pins. So that's why I'm taking, so pin more. So which pin we are using for LED? So 2 comma. So here LED is input or output? So what is the mode of this LED? So LED is output. So here we need to mention like mode output. So after the every ending of the line, we need to put the semicolon. So after that, we need to again define the GPIO pin for the switch. So here we use the 4th pin for the switch. So switch is here. So here the switch is an input device. So after the end of the line, we need to give the semicolon. So with this, we initialized the GPIO pins. Now we need to write the commands or we need to write the main logic of the code. Okay. So for that, I am just taking a variable A and defining it as integer. Here I have just taken a variable A. So now I am going to read the state of the push button. Okay. And I will store that value in this A. So A equals to, so digital read. So here we need to write the digital read or analog read. So here the button is also holds only 2 states, either high or low, open or closed. Okay. So that's why we need to take the digital read function and digital read. So which pin we need to read? 2 or 4? Yes, 4th pin. So we need to read the state of the switch. After that, give a semicolon. So I have just written a statement like A equals to digital read of 4. So this function will reach the state of the switch and it will store to the variable A. Okay. So now we will check the condition. So if A equals to high. So when A becomes high, so when we press the switch, then only the VCC go to the 4th pin. Okay. So in that case, we need to turn on the LED. So if A equals to A, so then we need to write like, so digital write, so 2 comma high. So when the switch is pressed, so when the switch is pressed means A becomes high. So at that condition, I am going to turning on the LED. So for how many seconds? So how to give the timing function here? So which function we will use to pause the operation for a certain time? Which function we will use here? Yes, delay. So here I am just giving a delay of 1 second. Otherwise here, if we don't mention the delay means, okay, first I will show you the output without delay function. Okay. So if A equals to high, the LED will glow. Otherwise, so else, digital write 2 comma low. So just give the semicolon. Okay. So this is our code. So after giving the all instructions, so just compile. That means start the simulation. Yeah, now it's working. So here just to change the connection. So here I have given the connection for B, but here we need to give the connection with the A terminal. Okay. So all of you just try to make the connection and try to write the code. So if you want, you can change the GPIO pin numbers. So if you observe the operation, so whenever we press the push button, then only the LED is glowing. So when we release, so that is going back to its off state. So if we want to, so if we press the push button once and if we want to glow the LED for 1 second, so here we can give the delay. So why I am giving 1000 here? So in delay, we need to mention the time as in milliseconds. Okay. So just stop the simulation and run the simulation again. So here, so if the push button is pressed, so I want to glow the LED for 1 second. So now you can see the change here, right? So if you want, you can change this to 5 seconds. To observe the variation clearly, so you can give the 5 seconds. And you can observe the change in the on time of the LED. It will be in on state for 5 seconds. So after that, it will go back to its initial position. Okay. Okay. So this is all about the switch concept. So with this, today's session is completed. Thank you for joining me in this session and happy learning.